Hello everyone, I am Dr. Joan Siat Ling. Now I would like to share with you on the subtopic of the circuit application for the Laplace transform. Now let's look at the example of the circuit. Consider a first order RC circuit, find the HS. So this is the RC circuit, resistor and capacitor. We have the input V in and the output V out. So let's use the Kirchhoff voltage law, KVL. Then we obtain negative VI plus VR plus VC equals 0. So this negative VI equal to IR, VR equal to IR. Then Vout is the voltage across the output at the capacitor. So it's 1 over C integration of IT dt equals 0. And then this integration of IT dt can be substituted with 1 over S IS. Okay, so now we have the VI, we have the IS. So we can factor out the IS. And then we move the VI to the left hand side. Or to the right hand side. Okay, so we have the V in S equal to IS. So we factor out the IS, we obtain the R plus 1 over SC. Okay, so we obtain the V in. So do you still remember the output V out equal to V in multiplied with the power response, the HS. So HS is equal to V out over V in. So we need to know what is the HS, or we want to calculate the HS. Since we know that the V out is the voltage across the capacitor, so V equal to IR. So now your R is the C. Okay, so the voltage across the capacitor is SC, and then the V in, we take the whole value of this one. Okay, and then we simplify. So SC, we can cancel out the SC, and then we cancel out the IS. We left 1 over RSC plus 1.
Okay, now look at another example. Find the system response for the RLC circuit. Just now only R and C, but now it's the RLC, which consists of resistor, capacitor, and the inductor. So based on the KVL, we can solve it like this. XT equal to VR, okay, voltage across the resistor, plus voltage across the inductor, plus the voltage across the capacitor. But this capacitor actually is the YT, is the output. So I name it as the YT. So XT, okay, VR equal to IR, so IDR plus VL. VL is DIL DIT over DT. Then YT is the capacitor, so 1 over C integrate IT dt. Then the Laplace transform of the system is so XT change to XS, IRT change to RIS, then LDIT over dt can change to LSIS, plus for this capacitor we can change to 1 over SCIS. Okay, then we factor out the IS. So this is R plus LS plus 1 over SC. So we know that the HS equal to output divided by the input. So your output YS is capacitor, right? So it's 1 over SC. And the input XS is this one. So it's IS R plus LS plus 1 over SC. So we can simplify it for 1 over SC divided by, we can simplify this one, so we can have okay, SC, right? Okay. Oh, I forget the IS here, okay? I forget the IS here. So after I simplify, I can cancel out this one. So I just left 1 over SC, and then I have the denominator also SC. So I multiply it, so RSC plus LC S square, LC S square plus 1 divided by SC. So SC and SC can be cancelled, then left 1 over RC AS plus LC S square plus 1. Okay, so this is the hash S. So if you want to rewrite also can, if you just leave like this, also no problem. So if you want to rewrite, you want to make it the S square at the front. So this one we have the LC, so make sure everyone is every term is divided by the LC. So what will you get? This 1 over LC divided by, so we arrange a little bit. So we take the LC square, so we change here, divided by LC, we get S square plus R over RC over LC S plus 1 over LC. So this one cancel, just have R over LS. Okay. All right.
The last part of the Laplace transform application is the system function algebra and block diagram. So Laplace transform can be used for describe the complex interconnection of the system. So there are two types of connection. That will be the parallel and the series connection in series. So for the first one here is the connection in parallel. For the time domain, the ht equal to h1 t plus h2t. But if in the Laplace transform or the S domain, that will be the hs equal to h1s plus h2s. For the connection in the series or the series system, the xt equal to h1t plus convolute with the h2t. Okay, is in the time domain. But if in a S domain, that will be the hs equal to h1s multiplied with the h2s. So this is the system function algebra.
Okay, now let's look at the example here. Solve the overall system functions. So before this, we need to change the xt in time domain to the S domain. xs, et change to es, zt change to zs, h2t change to h2s, h1t change to h1s, whereas the yt change to ys. Okay, now we look at one by one. What is the relationships between the input output? Okay, so first of all, we look at the y. So ys equal to es multiplied with h1s. So what about es? So es here is referred to the xs minus with zs. Then what about zs? Zs is referred to h2s multiplied with the ys. Okay, so the overall. So since we know the each input output relations, so what is the overall relations? So now what is the output? Output is a ys. So we start from ys. ys equal to es h1s. So es h1s. Okay, what is es here? Es is xs minus with zs. So zs is this one. Zs is referred to h2 s ys. Then multiply with the h1s. Okay, so we can multiply in. We multiply each one. So we get xs multiplied with h1s minus h1s h2s ys. Okay, so now we can simplify it. What is the output? Output is ys, and ys we can collect together. So ys, okay, we bring this one to the right hand side. So it's plus h1s h2s ys equal to xs h1s. So we factor out the ys, that will become 1 plus h1s h2s equal to xs h1s. So uh, so we know that what is the hs is the output divided by the input. Input is the xs. So the ys is h1s divided by 1 plus h1s h2s. Okay, that's it.